Yeah, today I came up with a special lesson for how to prepare a structural model from finite element software. Today I am going to choose ETABS software by CSI. So this is my architectural drawing. Here I have a house drawing. I have the plan views here, ground floor plan. Here you can clearly see the car porch, the pool and the veranda. And here you have the house area. You have the dining, TV, lobby, living, and some kitchens, bedrooms here watching. And this is the first floor drawing. So only this part is built up to the stories. Here you have terraces and balconies around, you can clearly see, and some bedrooms and lobbies. In this lobby, you have a large void. The staircase is clearly visible from the lobby through the void. So it is very important to avoid this beam part. And here you have this terrace area. In that terrace area, only this small portion is covered by a roof. So these parts are exposed to the sky. So this covering roof detail can be clearly seen in this sectional area. You have this roof is very clearly shown here. Another two elevation views, front elevation and side elevation is given in the architectural drawing. In this front elevation, here you can clearly see the isolated car porch, and this is the building which we are going to develop as a structural model. So the copyrights of this architectural drawing should goes to the original owner of this architectural drawing, the architectural planner. I'm only going to show you the structural model preparation. So I use this one only for that purpose. So the first most important thing is to develop the best structural form suitable for the structure. If you do any mistake in the structural form, that meaning of the structural form is where you are going to put the structural columns and beams. How do you drop the slab? What are the levels? So that formation should be developed most earliest stage. So you should not do any mistake in that structural form, otherwise you will have to suffer economically as well as in construction and architectural point of view. You will face lot of problems if you don't go for a suitable structural form. The most important thing is to prepare the structural forms. First of all, I am going to show the structural form developed for this relevant architectural drawing. After that, let's see how to prepare the structural model for this. Okay, now we have entered the ETABS software. First thing is to develop the grid system. Now here that can be done easily using file new model. In that file new model menu, there are some items shown here. Use saved user detail settings, so use setting from a middle file or use built-in settings. So I use this use built-in settings with thing. So display unit should be metric SI, and steel section database is taken as BS shapes 2006. Steel design code is BS 5950 in case if we need it, but in this house design we only use the concrete design code. So this is for ACI, already been ACI, so I'm going to use BS 8110 1997. So I will come up with this template. Here I can choose a blank structural object, and I can manually form the grid lines. Here you have some story data and grid spacing data. You can actually fill these options here, or you can later customize those details. Yeah. Now I'll come up with this blank interface. Or I can usually do, I can open a previously drawn model of a previous building. So I have this thing in my desktop, official PP here, latest. I have this calculation model file. Now I'm going to open a previously drawn model file. I have a previously drawn model. Then the data I have used for this relevant model is saved here. So I'm going to use the same template and again create the new model in this interface. So first I'm going to unlock this previous model and I select all and I delete it. Now I have this blank interface, but the previously drawn grid system. So I can change it to my new grid system by right clicking in this background, and I can go to add modify grids. And here G1 grid system is modified here. I can modify this one to the latest one. Here you can clearly see reference points are drawn. Several reference points are drawn for the previous model. So I'm going to delete them. Here I have all the reference points. I can delete all of them. Okay. Now everything will be deleted. Here I have X grids data and I have Y grid data here. X grid data. According to my new model, X grid data system is 1. Here 1. We have 2, 3, 4, 5, 6 and 7. The spacings, I'm going to delete the rest, and I can enter the ordinates or the spacings. If I tick this here, I will come up with the ordinates. So grid 1 to 2, in this relevant house drawing, I have 20 feet 6 inches. I'm going to convert those to in metric. 20 into 12, 240 plus 6 inches, 246 inches, and I will multiply it by 25.4. Then I'll come up with the millimeter value, 6,248. So I'm going to enter it here, 6,248. Likewise, I'm going to fill all the coordinates here. Okay, in X grid data system, all the spacings are done. I can check whether it's okay. Yes, it's changed here. And I'm going to change the Y data system according to my new grid system. So I right click it again and add modify grids. I go to G1 grid system and modify show grid system. Then I can modify them here from A to something. So my grids are A, B, C, D, E, F, G, H, I, and the rest are not needed. So I'm going to delete them. Now I tick here display grid data spacing, and I'm going to fill the spacing. Grid A to B, I have grid A to B. I I have 17 feet 3 inches. So I'm going to convert it to millimeters. 17 into 12, I have 204 plus 3. That means 207 inches. In order to turn it into millimeters, I am going to multiply it by 25.4. So I'll come up with 5258. So 5258. Likewise, I am going to fill the rest. Okay, I finished filling the Y spacing here, and I click OK here, and I'll come up with a new grid system which is suitable for my new design model house. So I have this grid system. Now I can start drawing the model by placing the columns in the places. Before that, I'm going to tell you about defining material things. Defining material properties is here. Define material properties. You have concrete here. 4000 psi is for concrete. Modify show material. Here you have the same name, and you have the parameters of the concrete. In this design property data, you can modify the available cube compressive strength here, FCU. So I am going to use 20 compressive strength grade for this relevant house design, because most of the masons use this grade for domestic concretes. If we go for ready mix concrete, we can find out 25. That is okay, because we actually do the design for 20 MPa, but you can use 25 MPa concrete. So for more safer situation, I use 20 MPa concrete cube compressive strength here. So that is about concrete. And here you have the steel. Here you have the steel. A615 grade 60 is the steel rebar material. You can go to modify and you can look at the each and every property of this material, and you can modify the material properties here. Here we use 460 MPa yield strength rebar, so that I made this number to 460. In some cases, some people use 500 bars, MPa bars, but in a safer situation, I use 460 yield strength. So that is all about material definitions, and we can define the section properties. Actually, we have two types of line members, columns and beams. We have one single type of slab members, that is the area members, that is slab. So we can define section properties here, frame sections. In frame sections, we can define these columns. I have already defined column 225 into 225. These are the ordinary column sizes used in domestic design or house design purposes. I can use the the parameters inserted for this relevant column size by going to this modify show property. In that case, the name given is this one and the sizes are given here. So 4 bars are assigned to this one. Here you can clearly see 2 for one directions, 2 bars for another direction. Likewise, I have defined 4 bars. So that section is already defined. Likewise, you can define the beam properties as well. Here I have defined so many sizes to be used, beam sizes to be used here, and easily I can pick one and assign to my model elements. Okay, that is about element design. So now I am going to draw the columns here. Okay, let's draw the columns. Draw beam column beam objects. Here I have several options. I am going to select this quick draw column plan view. Here, in the plan view, you can quickly draw the columns using this relevant feature. Here in the property, you have to select the column section. So I am going to use here is column 225 into 225. Yes, here I found it. Now I selected the column property and now I am going to place the columns needed in my relevant design. So here I have a column in grid 6I. Grid 6 is this one, I is this one. So my column should be placed here. It's not placing because I choose one story option here and I am in the basement. So I am going to go for the first floor. So I use this arrow. Then I am in the first floor and I apply this all story options. Then I can delete the unwanted column parts later. So in 6i grid I have a column, and also 7i grid I have a column, and also here one single column, and here another one. Here another one. Here I have a column there, and here I have one single column. Here I have one. Here I have one. And here I have one column. Another column is here, and the one is here. Here. The other one is here. This is a column for porch. Here I have another one. And now I have a few columns here in the places where a suitable grid is not available. So I have to go for the reference points. I have to find the distance from one single reference point to here. And I'm going to insert those for that thing I will do later. Before that, I'm going to place the other all columns. So I have 3 columns remaining. They should be placed somewhere here, somewhere here, somewhere here. So I'm going to use reference point options. I go to draw and reference point option. In reference point option, I have to give x distance and y distance from a relevant defined point. So I have to find out the actual distance here. I have to go for the architectural drawing for that. I am opening the architectural plan and trying to find out the reference point dimensions for the columns which are not situated in a proper grade. Those are the points which are out of the grid system. Here I go to this plan and I was talking about these points. So I'm going to measure the distance. Here in this relevant point, there is 3 feet and 6 inches. You can find out that in the decimal units. Here it will indicate here, that is 1054 millimeters. This one, 1054 millimeters. So I have 3 columns like this. So I'm going to draw these 3 points, 1054 in the y direction. So I define for the y directions 1054 millimeters is given minus, because I'm going to draw them from by these points. Here 1, 2, 3, all the 3 points drawn. Now I can place the columns in that reference points. So I go to draw, quick draw columns, and already the member property is defined here. So I will draw here, but here plan offset previous number has come to this place, so I make it 0. Now I can draw the columns. Okay, all the columns are drawn now. All the columns are drawn. Now I am in first floor. I can go to the every level and find out whether they are available. We'll show you the columns in a 3D view here. You can have a 3D view. Yes, all the columns are shown here. Now we can draw the beam elements. So I go to first floor and I'm going to draw beam elements. Here draw beam column icon is here, and you have to select a beam size. I'm going to use beam 224 into 300 deep beam, this one. So I'm going to make this space wider. Okay, here I have a beam here. Every time I try to use the same pattern from left to right, I always try to draw the elements, the line elements from beam elements from left to right, because then it will be very easy for me to find out the results. The diagrams will be, the output diagrams will be given in a proper directions if I use that one. And here I'm drawing the beams. I have a beam here. Okay, in this direction all the beams are drawn. Now I am trying to draw the other beams in y direction beams. Now I think I have drawn of them. No, I have some small beam parts here. In order to draw those beam parts, I have to find these reference points. First of all, I will define these reference points first. And also I have a balcony part here. For that also I should have some reference point somewhere here. And I have a small balcony part here. For that also I should have two reference points. Here. Here I have some balconies. I'm going to find out the distance from here to the edge of the balcony. So it will come with 3 and 5. 3 feet and 5 inches. When I go for alternative units, it will show the millimeter number 1049 millimeters. So draw reference points, x direction 1049 millimeters, 1049. So I can draw those 2 points here. No, it's wrong. It's not x direction. It should be in y direction, 1049, and this x value should be 0. So I drew the both points. When you draw into these points, be careful because you have two different points very close to each other. So be careful. Use zoom option when you are drawing this kind of sensitive situations. Here I have 1028 for this balcony. So draw reference points. What did I say? 1028. So in the x direction, I have 1028. And also here I have 1333. 1333. So I will erase this beam part and redraw it. And here I have, that is 1361. Okay, all the reference points are drawn. I'm going to redraw these two beam parts, delete them. I'm gonna redraw. And here also I have two beam parts. Here. Do I have a beam part here? No, I'm not going to use beams for this relevant balcony. I have to get some one reference point here also. See that balcony? No, this is a veranda. Veranda is coming to here. It's in the basement, so that no need to include that in the 3D model. Balcony is just come only to this place, so I can use it there. So let's draw these slabs now in our model. So slab is an area element. So slab is also element. Slab element also should be defined in this software. So you can go to define menu, section properties. You have slab sections. That slab sections you can add a new property by giving all the parameters. So I have already added some few sizes, beam slab sizes here: 100, 125, 150, 165, 175 and 200. So in case I can use whatever I need. I usually use the minimum slab thickness as 125 millimeter slab thickness. So we can start drawing the slab. Draw. Here you have the line elements. Here you have the area elements. Yeah, the first option, draw floor wall plan, can be used. And here in this property, I have to select this slab property, slab 125, which was defined earlier by me. So 125 thing. I'm going to draw a slab. When you draw in a slab, better to use a sequence, proper sequence for that. That will be good. Right. I can draw the rest. Here I have a balcony. Here in this case I am using the counterclockwise directions for drawing the slabs, or else you can use the clockwise direction, but I recommend you to use one method. That will be very easy for you to by reading the results. Now I have another problem here, because I have a large void in the first floor. So without void I have to draw the slab. So in order to identify the margins, the positions of or the boundaries of the void, I have to use this reference point option again. So I have this draw reference point option. First of all, I have to find out the dimensions to the edges of this void. We'll do it. Here I have the void. These dimensions can be taken. It's 4.2. That can be find out by switch on the alternative options. So this dimension is 1282, and I have to again find out these points. I have this point. And this one. Okay, I will define this one. 1282. 1282. 1282. So reference point can be drawn like this here. And this dimension is this. That is 1320. 1320. Okay, I have done this one. Now I can draw a slab element here. Okay, and I have a balcony here. And also I have a slab here. I have a balcony slab here. Oh, I have missed a beam. Yeah, in this direction I have to put a beam. For that I have to calculate the dimension here. This center point, this grid is 6 to 9. Going to find it out in the millimeters. That is 2048. 2048. I should have some reference point. 2048. Reference points. 2048 minus 2048 minus 2048. Okay, now I have those two, and I can draw a line beam element here to here. I can draw the slab elements here. I made a mistake, so I'm going to undo it and do it again. Always be careful to draw to the exact point, otherwise you will come up with errors and problematic messages in the analysis stage. Now here I don't have a beam here. I can't have a beam here. I explained it earlier, because through the void the stack is visible to this lobby, so it is interrupted with this beam, so I'm going to delete it. However, I have to draw the staircase here. For that I should have to take some points here and use some dummy columns, and later I can delete the columns. I put those columns for the easiness of drawing the staircase. Okay, for that I have to use a slab here. I'll try to show it. Now the problem here is, you can clearly see, because I use that all stories options. Now I can start customizing the things. I made this to one story, and I can select the slabs on the basement, ground floor, and I can delete them. I can do that for the above floors if needed. But in this stage, I'm going to delete all the above things. Yeah, likewise I can do it. There are some other easy methods even. Now I only have the columns. All the beams and slabs above are deleted. Okay. Now I have to, my big challenge is to draw the staircase. For that I drew a non-beam here and another non-beam here, and I divided this part into two. And in order to start the staircase, I have to draw a column here in the basement. I should have a beam here in the basement. I use a none beam, the property is none, and I draw it here to here. Now I can divide that none beam into two parts. Edit frames, divide into two objects, apply. Now it is divided. Now you can start drawing the staircase using this part and the first floor, these parts. So I'm going to draw the slab in the same thickness of the staircase, slab 125. I use first point as this one and the second point as this one. So sorry. The upper part is this one. So I use the first point as this one and the second point as this one and the third point as this one and the fourth point as this one. Now you can clearly see I have drawn this one, but staircase should be not like this. This has to come to the intermediate floor. So I go back, and this part should be developed in the intermediate floor. So how to do it? You can divide these two columns, these columns, you have columns here. You can have another column here, dummy column. Later you can delete it. Draw column, dummy column here. Now it can be easily done. You can go to 3D view. Here you can have this column, this one and this one, and another column here. Those four columns can be divided into two parts, equal two parts, divided into two frame objects. Now you have some points in the intermediate level. By using those intermediate level points, you can connect them with none element, none beam element. Yeah. Okay, now you can draw the landing slab there. So you have drawn the landing slab. In order to draw the steps, you have to divide this part into equal two parts. And also the top one, the first floor beam which receive the steps have to be divided into two parts. Now you can draw the staircase. First step can be drawn like this. Here, here, and here, and here. So first part is drawn, and the second part here, 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 here. Yes, your staircase is simply drawn here. You can rotate it and look. Now I can delete the other columns, the additional columns used for this part. But before that, I am going to look at the above part of this staircase. After finishing the above part, I can delete the columns I have used. Okay, let's see. Now I am going to draw the second floor. This is the first floor, and I am going to second floor. Second floor is empty because since we have on these options for one story, so I will pick my second floor or simply rooftop plan, and I am going to draw the beam arrangement of that rooftop plan here. I have already selected non-beam type, so I have to change it to beam size option B225 into 300. So my beams are like this, and I quickly draw them all. Okay, in the other direction beams can be drawn. When you use a proper sequence, it will be easy for you to handle the model. The sizes of the beams can be adjusted later according to the results. Results means the bending moment diagrams and shear force diagrams. By looking at those, the required sizes can be provided, but for that you have to collaborate them with the architectural requirements as well. So these are the beams proposed for the second floor. Now I can draw the slabs in the second floor. I use the same thickness. This thickness also can be changed according to your preference. Actually not according to the preference, it's according to the requirements. I made a mistake, so I'm going to go it back. Oh, here I don't have a slab here. This part will be a roof. And for these parts, I draw the slab. Here also I have a slab in this relevant part. Here also I have a slab. And here also I have slab. Here I have the staircase, which is used from first floor to roof terrace. So I have to take a look about that here. As previously we did something like this, not this one. What are the columns? Wrong. Here I haven't a column here, so I have to draw a dummy column here. Otherwise I can't manage with the blend-in level, so I have to use a dummy column here. To draw a column. Okay, now I can divide those column parts to equal two parts. Those columns to equal two parts. I can go to these options, edit frames, divide frames, and divide it into two parts. Here I can use dummy beam or non-beam options to draw the beams in the land-in level. Here the midpoints will be highlighted very easily. This one, this column, that's the midpoint. And find out the midpoint. Here. So I drew it easily. Now I can draw the slab. I use the same 125 thick slab to draw the land-in level. I'm going to divide this beam part and this beam part into equal two particles. Yeah, I can start from these 2 points and I can finish from these 2 points. Alright. And again I can start from this point and this point and this point and this point. So I have finished drawing the staircase. Now you can delete the dummy columns if needed, if those columns are not needed. So I don't need these columns. This is a dummy column I used, and what about this one? This is also a dummy column. This is also a dummy column. This is a dummy column, and this one is a dummy column. So I'm going to delete these dummy columns. Delete. Now you can clearly see staircase is smoothly drawn, and we removed this beam part here, so it is very clearly visible. So everything is okay. Hope everything is okay. We are trying to load this landing to the wall part below. So it should be load bearing wall here. We have to indicate that in the drawing. Otherwise, later the house owner, if he decided to demolish that one, everything will be collapsed. So be careful about that when giving the instruction to the owner or giving the instruction in the drawing. So you have to clearly identify this one as a load bearing wall. Otherwise this will be not last long. Okay, so this is the rooftop plan, and when you go there you don't have another level of slab level. Only a roof part will be given to this portion. So I am going to use these columns in the above also. I have to use a column here. It is shown in the architectural plan. So I'm going to use a column here. Draw. Okay, it is drawn now. Now I can smooth the model by deleting the unwanted things. I can go to the 3D model. I can clearly see the unwanted columns here. I told you in the architectural drawing, only this small part. Has a roof here. So these columns should be given to the above level. So other columns, I'm going to delete all the other columns. These two columns are not needed. And here, these columns are not needed. And what else? These columns should be there, and let's let this column be there, because there's a water tank part and we can do any arrangement. We can have any arrangement using this column. So let's let that column be there, and let's delete these two columns. These two columns can be drawn. Now the roof load can be applied to these columns. So our 3D model is drawn and that is finished. We can now apply the loads and do the modifications to the load bearing things and the supports, and the drops can be released for the moments, and those things can be discussed in the next part. Alright, I couldn't tell you here. We have two slabs now. For this roof terrace slab, they will produce a roof for this one. So the columns goes to that level, but in this level we can produce a roof beam. We can say use 9 inch by 9 inch RCC beams for this one for time purposes. So we have to apply it inside the model. Yeah, our columns are freely waving on the top. So in order to stop that, we can use a tie beam set, roof tie beam set here. So I'm going to use beam 9 by 9. That means in millimeters 225 beam in order to tie all the columns. Alright, I have already produced this roof beam set here, but you can clearly see there's a problem. So there isn't any problem. We have to adjust the story heights. Add modify grids. Here you have modify show story data, and here you have several levels, but you only need first floor level, second floor level, and the roof level. So you have to edit the other two. These two can be deleted. Delete story, delete existing stories. Now you have first floor, second floor, and this can be renamed as roof. And the story heights have to be inserted in this column. Here we have given 3.353. Here also 3.353. Here also we will produce 3.353. Now you hop with the completed model, but it doesn't show the height difference. Let's check it again and modify grids. Modify show story data. Here this have to be adjusted. This is 3.353. Okay, it is adjusted. Okay. Now it's okay. Now the roof beams are there in the picture. Now we have to apply the loads in the floors. The floor loads. Now this is my first floor. Floor loads have to be calculated using the loading code of practice. BS6399 can be used to determine the live load. Since this is a house design, we can use some minimum live load applications. I usually use 1.5 kilonewton per square meter for all the floors for calculating the live loads. And also for the finishes, I usually use 1.5 kilonewton per square meter, or I can simply use 1.1 kilonewton per square meter. So I'm going to show you the load application thing. I selected all the slabs in the first floor, including this staircase landing slab. I go to assign shell loads uniform. In that uniform window, I apply dead load, that is for finishers 1.5 or simply 1.5. Apply. And again I have to select all of them. Instead of selecting one by one, I can go to this PS option. PS means previous selection. Then all the previously selected slab elements are selected. Now I select live load here. I use 1.5 kilonewton per square meter for the live loads for these slab elements. Okay, first floor slab loading part is done. Second floor, I have a few elements. I assign shell loads uniform live 1.5, again previous selection, dead 1.1. Okay, but I have to some important slab panels for bathrooms and fillings and everything. So I have to take a look about those important slab panels separately for more loads, because there are some fillings in the bathrooms. There are bathroom drops for taking the water tubes, etc, etc. After that, we have to fill that to cover the tubes using brick fill or in situ concrete. That filling load have to be calculated here. Now I have bathrooms in these panels. Yeah, in this panel I have bathroom. So I am going to consider I have another bathroom in this panel. These two panels have to be filled. Filling load have to be calculated. I consider 150 millimeter drop and filling of 125 millimeter concrete. So 0.125 into 24 will give you 3 kilonewton per square meter filling load. So I'm going to apply it. Yeah, in this bathroom, two bathroom panels, I'm going to assign uniform dead load 1.1 for finishes, 3 for filling, altogether 4.1. 4.1 load should be applied to the dead loads of these two bathroom panels. I applied it. The self weight will be automatically calculated using the software, so I am not going to externally applying it in the slab panels. That is okay. Now let's consider about the second floor or the rooftop. Here, rooftop loads are like this. Here I have to apply some separate loads for this flower trough parts. Flower troughs are heavily loaded because of the soil infill and the plant weight. We have to consider those two weights. If I have a kind of a section of the architectural drawing, I can consider the heights. Here I have this part. This part load should be applied in the relevant part, so I am going to find the distance. Here 2.5 feet. 2.5 feet means 750 millimeters. So 750 millimeters area should be separated here and also here and also here. So this have to be highlighted in the model. This is my model. I take it here. Now I can see both the drawings. In order to draw this 750 millimeter wide strip for plant troughs, I have to go for reference points. Here 750 millimeters. I'm going to separate this one 750 millimeters, and again here 750 millimeters in y direction. Let's say minus 750 direction. Here. Now I can draw this line, and here also I have to take positive 750 in y direction. Then I can separate this part. Here also I have to do the same thing. Again minus 750 should be taken in x direction. It starts somewhere here, so I have to go for another around 750. No, it's around 1.5. So this is 1.5, so it's very large. Let's take 1 meter. Let's take 1 meter. Alright, again another 750 from here, 750 in x direction. Now we can separate the flower part by looking at the architectural drawing in the 3D model. So I'm going to use a non-beam for separating this area. Right, I have to delete this part. Now I have a line load. I can apply the small wall part, line load, when applying wall loads. Before that, I have to apply the slab loads here. For that, I need to separate this small part from the slab panel. Here also the same. Here also the same. Now I can go edit shells, divide shells, and cookie cut for objects at selected frame objects. Now these parts are separated. Now I can apply the filling load for this slab panels here, but first of all I have to calculate the filling load. When I go here, I can clearly see the soil will be infilled to this height. That height is around 1.5 feet. 1.5 meter is very much similar to 450 millimeters. So 450 millimeters height I consider a soil infill. So 0.450 into 18. 18 is the density of the soil. So I will come up with 8.1. So I'm going to use 8 dead load for these areas. Design, shell loads, uniform, dead is 8.1. Okay, now I applied the flower trough load separated. Flower trough load is applied. This is section S. There's a small part here. Let's go to see section X. Here roof slab is inserted there. We couldn't draw that slab part in the drawing, so we have to draw this slab part as well. So I go here. I can draw this slab part starting from here using these points. Okay, I'm going to draw this one. Here I drew this one, and I have to apply the shell loads here. Dead 1.5, 1.14 finishes, and also the live load should be applied. I take 1.54 live loads, so I applied that. All right, now it seems that all the slab loads are applied. So what are the missing things here? Here we have this water tank. This water tank, in order to use this water tank load, let's apply this water tank load to these brick walls and as line loads. So when we are applying the line loads, we can consider these loads in the slab element. But for that, we have to draw these lines as non-beams on the slab. So I'm going to draw it. Let's go to the line element option, and non-beam option is already selected here. Yeah, I can take it somewhere here, and I can go somewhere here. Green color thing is perpendicular items. You can easily draw it. I have to separate these two into two slab elements through this non-beam. So I go to edit shells, divide shells, and cookie cut object, then it will be separated. Now those are two. Now we came to the end of applying slab loads to the structure. Now we can start applying the line loads. Before that, we can save the model. File, save as. Model. I save as number 1. Okay, now let's take a look of the line load applications. Yeah, when I go to the first floor slab, yeah, I have the first floor slab. When you look at the architectural drawing, you can clearly see so many walls going here and there. So all the walls are flush to the columns so that the column lines are not visible. So that is good for architectural view. Here they have used 9-inch wide walls. So I have to take the loads of these 9-inch wide brick walls from bottom floor to top floor height. So I have to calculate it. When I calculate the wall loads, 0.225 into 21 into, let's say the height is 3 meters, then we'll come up with 14.1. Let's use 14.1 load everywhere. If you like, you can reduce the wall loads in these door and window areas. Now, by looking at this, I can clearly see the places where the walls are available. So I'm going to click all the places like this and then going to apply the wall loads on it. Here we have wall loads everywhere. Let's reduce the loads after applying the loads. Let's reduce the loads for windows and windows later. Alright. Yeah. Now you can clearly see here the wall is going in this kind of line. So that we have to use none beams on the slab. So I will clear what I have selected, then I will start to draw those none beams. None is selected here. I'm going to draw that none beam. Okay, I drew it. Now I select all and going to apply the wall load. Later we will reduce the loads for the voids. I will consider all of these lines as walls. Here we have walls. Here we have walls. Here we have walls. Here we have walls. And here this one. Here. This one. For the moment, these lines will be enough. I am going to go to the assign frame loads distributed. In that distributed thing, we can give a uniform load value here. We calculated it as 14.2 kilonewtons per meter. It's a line load. Line load means wall load that can be applied from this menu. So the applications are clearly visible here. Now the small adjustments can be done to this relevant plan. Now when you go and take a look here, you can clearly see 3 feet height handrail. Handrail weight is bit negligible when considering with the wall loads. It is less than always 1 kilonewton per meter. So you can simply neglect those line loads. And when you look at here also you have the handrail, here also you have the handrail, here also you have the handrail, here also the handrail. What about this one? This is also handrail. So this load also can be neglected when applying to the model. Now let's reduce the line loads by considering the openings. Here you have a grand opening and it also goes to the sill height. So you can simply do click it, assign frame load distributed. Please apply the reduced load here. So let's apply around
4 kilonewton. That will be more than enough. And here also you have balcony doors and windows and some decorations here, so it will not that much heavy, so you can reduce that thing into, say, I'll use 6. And the same thing happens in this balcony. This load can be reduced, but that is drawn as a single line. In order to separate that, I use these 2 lines and I go to edit frames, divide frames, and from that option I use break at intersections with selected frames and joints. Then I can separate those 2 elements. Then I can simply select this individual element and apply the relevant load. Here I will apply around 8. So what are the other places where the loads can be reduced? Here you have a grand opening, so you can select that element and you can apply the load you preferred. I prefer 5. And here also you have grand opening. There also you can reduce the loads. I prefer 8. Likewise, you can apply the reduced loads for doors and windows. Alright, now we can apply the line loads of the second floor or the roof terrace. Here I have the roof terrace part. In the architecture drawing, I am going to select the roof terrace drawing. I can clearly see that small wall part should be gone along this flower trough area. That can be clearly visible here in the section of the flower trough. So I can measure the height of this part, that is 1.5 feet, and the breadth should be taken, it's 4 inches, that means 100. Say if they use 150 brick, so the breadth is 150, the height is 450. Breadth into height into 21. 150 into 450 into 21. I'll come up with 1.4. So I can apply 1.4 for this small wall particle. Here I have that wall in these lines. I select those. And I'm going to assign frame loads 1.4 magnitude. Alright. Now what else special features do I have in this roof terrace? So then I have 3 feet high guard wall around these areas. 3 feet high guard walls. Here also I have the same thing. 3 feet high guard walls. So I can apply 3 feet high guard wall load to these lines. This line and this one and this one. Here this one and this part. This one, and also this one, and this wall, and this wall. Now I'm going to calculate the 3 feet high guard wall load. 3 feet is 900 millimeters. So 0.9 into 0.225 into 21 will give us 4.2. I use 4.3 value. So I am going to assign that 4.3 kilonewton per meter line load to this relevant line elements. And now I can clearly see there are some much higher walls. These could be much higher walls. So for these walls, I'm going to use the full height. I will take 10 feet high wall loads. For that I can apply 14.2 line load in these relevant line elements. Yeah. Assign, distribute 14.2 line load. Yes, that shape can be clearly seen in this side elevation. This side elevation, you can clearly see that much higher wall here. And this could be the 3 feet high wall, I think. Yes, it's the 3 feet high wall. And also here we have much higher wall. The wall height is 6.6 and 6 feet and 3 inches. When I calculate it, 72 plus 3 into 25.4, that is 1905 millimeters. 1905 millimeters into 225 into 21 will give you 9 load. The magnitude of the load will be 9. So I am going to apply a load with 9 kilonewton per meter square. Design 9. So I loaded these two beams as well. When we go here in the rooftop plan, we applied these loads and we applied full height load for this one. We applied the 3 feet or 900 millimeter high wall loads to these walls, and here I have some few height wall full height walls here. So I am going to apply full height wall loads to those beams, and here also. Design frame loads 14.2 kilonewton per meter square. So we have done it, almost done it, but you can clearly see a door here, a door here, a door here. So for these lines I am going to apply very smaller amounts of line loads for considering the door, or by considering any changes of the door features. So I am going to apply around 3 kilonewton per meter line load. And when you consider this water tank, you will have to build up the walls here, and on top of that walls you have to place the water tank. So the water tank load should be distributed in the slab, which is to be placed on the top of these brick walls, and through that slab the water tank load will be transferred to the 4 walls in the 4 directions. So 14.2 will not be enough for these loads, these line loads. So we have to increase the loads by considering the water tank load here. I will do it. Okay, and also when we considering the section of this house, you have these beams here. These are in a level, in a higher level to the roof slab. We used that one. We drew those line elements in our model here. But the problem is, you can clearly see some beams to be gone between F and E grids. Here, F and E grids are these two. Here you will have to have a beam. So this is correct, because grid C and B should come here, somewhere here. So this is a bit shifted, I think. Whatever it is, I have to consider this beam as well. So I have to draw that beam. I have to select the beam type, that is this one. Beam comes here. So I need to find out the load which is coming to these beams. So when I go to find out the height of these walls, I came up with it's 5 and 1, 5 inches and 5 feet and 1 inches. That means 5 into 12, 60 plus 1, 61 inches. 61 inches is equal to 1500 millimeters. So 1549 millimeters can be the wall height. When we consider that 1549 wall height, I can calculate the load relevant to that one. 0.225 into 1549 into 21. I'll come up with 7.3. So I am going to use a 7 kilonewton per meter load for these each and every beam here. It's 7.3. I'm going to use that load. Design frame load 7.3. But when you come here in somewhere here, load can be reduced. I'm not going to calculate that the exact value, but I can roughly reduce the value by looking at this wall height. So I can apply around 6 when I look at this small part, I can apply around 3 kilonewton load here. For these two parts, I can apply around 4. I'm going to let these values be there. Okay, now I have finished that part. So we have done with the line loads. Our model is now, I hope the model is completed. Now what I can do is I can clearly take a look about these elements. I remembered that I have to apply the slab loads to the staircase thing. So I'm going to assign the slab loads, shell loads uniform 1.5 live load, and again a dead load. I'm going to use 1.5 dead load. I will not reduce it to 1.1. Now it seems that we have done with our 3D model. Now what we can do? Now we have to mesh the entire model. Actually, the meshing will not be applied to the line elements. The meshing has to be done to the area elements. So I calculate the area elements. When I calculate everything, when I apply the meshing thing to the entire model, it will be applicable only to the shell elements. So I'm going to use select the model. I'm going to assign shell flow auto mesh option. So I'm not going to mechanically divide this into smaller pieces. I'm going to give a kind of automatically mesh option. Before the analysis part, they will consider, the software itself consider the meshing option. So I prefer to use this option here, auto cookie cut object into structural elements. There I can pick 4 places: mesh at beams and other meshing lines, mesh at vertical inclined wall edges, and also mesh at visible grids, and also further mesh where needed to maximum element size. I'm going to use around 200 millimeter smaller mesh. Okay, I gave it here. Now my meshing thing is also complete. I saved my model, and before going to analysis part, I have to tell something about this this load combination part. I can define the load combinations from this define menu, and here load combinations. This load combinations, previously I defined these 2 combinations. First one, com1 service, that is for service condition. When I go to modify show combo, I can show you the safety factors or scale factors I have used here. For dead and live, both I used scale factor 1. That is because service loads are coming from this combination, and the foundation reactions will be found using this combination. And I used another combination named as ultimate. When I go to modify show combination, I can see what safety factors I have used here. According to the code, I have to use 1.4 safety factor for dead loads and also 1.6 safety factor for live loads. But here, when we considering this type of simple house designs, we use brick loads and although we didn't consider the load bearing walls in the design process, it happens when construction is going on. And also there are so many parameters supporting our structure. So by considering the economical situations, I have lowered these scale factors to these numbers, 1.16 and 1.2. That's your preference. I just showed you the load combination definition part. The load combination is also complete. Now, before coming to the analysis step, I can check whether we have some faults or errors or any disputes in this model. For that, I can use analyze check model option. There I'm going to select all the checks and I press OK. Now the software itself check and show me whether there are some silly mistakes I have done. So here the warning message is given as model has been checked, no warning messages were generated. How lucky I am, I don't have to correct things again. We have done the model very carefully and perfect. Now we can go to the analysis part. We can use this small arrow rectangular icon, or we can go to the analysis and run analysis. It didn't take much time, and I hope it's becoming ready. You can clearly see it's analyzing the model, and the percentages can be seen in your left bottom corner of the software window. So it's happening. Finally, it's happening. After the analysis part, you can come up with the deformed shape. In this 3D window, you can clearly see the deformed shape of the building. Don't be nervous by looking at this. These are scaled. So in order to show a clear shape of the deformed elements, they have given this one. When you zoom the structure, it will not have that much of bend as you think, as you thought. Now you can take your mouse to the points in the analyzed deformed structure, and you can find out the deflections. As an example, if I take my mouse here, you can clearly see UZ value, that is the deformation in the Z direction, is 4.332. That means this particular part of the building is deformed in the downward direction by 4.3 millimeters. Likewise, you can find out the deformations. Please make sure that you have selected displacement for dead. These values are shown by considering the dead load case. So this is the deformed shape. Now you can clearly see the bending moment diagram of this structure, and by considering that those bending moment diagrams, you can apply the reinforcement areas to the places, the places of those elements. I'm going to show you display for stress diagram, frame pair. Here combo to ultimate is selected, and moment 3 apply. Here you can clearly see the bending moment diagrams of each and every element. If this is not that much clear, you can go to the plan view. Go to the plan view, and again you can go to display option for stress diagram, frame, pierce, and that thing, combo ultimate, moment tree, apply. Here, this relevant beam has this kind of bending moment diagram. Here, that beam has a sagging moment of 43, and here that beam have a hogging moment of 23. Likewise, by considering these values, you can assign the rebar or steel required for this model. If you have much higher moments, that means if you can't use 225 by 300 beam for this relevant moment, you have to increase the size of the element. Here you have a such situation, 59 or 60. It's very difficult to assign reinforcement or rebar to 225 by 300 smaller size beam. So by considering this value, you can increase the size of these elements. That is a kind of rigor analysis or something. You have to, by looking at this, you have to first decide what elements I am going to increase the size. Then you can increase the size and again analyze and again come here, and you can then, by considering that value, you can assign the rebar. So that's it. When you going using these arrows, you can see the bending moment diagram from different floors, and how to find out the reactions for foundations. I'm going to show it. Display, force stress diagram, support spring reactions. Here, combo. I'm going to find out the service combination reactions. FVZ, arrows, apply. Here, they will show the base reactions with an arrow, and by marking the value there, 104 kilonewton reaction is coming to this relevant column. When you consider this column, it's 175 kilonewton reaction. Likewise, it shows the reactions. And if you are preferring to do the reinforcement concrete design using the software itself, you can go to design, concrete frame design, and start design check option. Before that, make sure you have completed these parts, the preferences, rebar selection rules for beams, select design groups. When you complete these things, you can come to this start design check. Let's see what is happening. So I did the rebar design using the software itself, and I came up with these diagrams. What are these values? The software gives values for beams as well columns. So when you consider these columns, you can clearly see these numbers. These numbers are the required reinforcement. As an example, 434 square millimeter rebar area is needed for this relevant column, 225 by 225 column. So if we apply 4 T12 bars, each T12 bar contains an area of 130. If I apply 4 T12 bars, the total will be 452. So the requirement is 434. I apply 452 by applying 4 T12 bars. Likewise, I have to decide the column reinforcement for each and every place here. When I take a beam, when I consider a beam, if I take this beam, you can clearly see here this below number 75 is referred to the sagging moment. So I have to provide this much of square millimeter rebar for sagging for the bottom section, and also these 75 and 82 numbers are for hogging moments of the beam. So I have to apply rebar equal or higher than this number for the hogging moments of the beam to the top of the section of the beams. Likewise, I have to apply or assign the required reinforcement. And I have go several checks using this ETABS model. I will show you how to design the slab using the ETABS software itself in my next video. Hope you took so many things from me, and this is a long process of designing an entire house using finite element structural design software. So hope you gained a lot. Please be with us. Let's learn together furthermore things in structural and civil engineering. Subscribe our channel and please share it for others. Goodbye. Have a nice day.